Okay, so here's the last video where we're going to continue with our review. So here's the first question. We are given a composite shape and we're asked to find the perimeter. So we know it's called a composite shape because it's made up of a couple of different shapes, or at least two other regular shapes. So when it asks us to find the perimeter, we know that that means we're looking for the distance all the way around the outside of the shape only. So we can see we already know that this whole length is 7, this whole length is 3, this whole length is 3, and then this length is unknown. So that means we have to start by finding out what that length is. Now I can see that that length is part of a right angle triangle, and specifically it's the hypotenuse. So because it's a right angle triangle, I know that it obeys the Pythagorean theorem, so I'm going to try to find out what this length is and what this length is, so I can use those two lengths to find the third length. So I have to do a little bit of detective work here. So for the first thing to notice is that this length across from here to here is the same as this length here. So that means that this side of the right hand triangle must be 3 centimeters. Now the next thing to notice is that because this side is 3 centimeters, so is this side. That means from here to here this is 3 centimeters, and we know that the entire thing is 7 centimeters, which means that this other side of the triangle, the last part of this little segment, must be 4 centimeters. Okay, so we have a right angle triangle, 4 centimeters, 3 centimeters, and we're looking for the last side. So we use the Pythagorean theorem. A squared plus b squared equals c squared. This time the hypotenuse is the one that we don't know, so that means that we're solving for c. We're plugging in 4 and 3 as a and b. So 4 squared plus 3 squared equals c squared is now the formula that we're looking at. We are using BEDMAS because c is almost totally by itself. So exponents come first, so 4 squared is 16, 3 squared is 9, and then now we're going to add them up and we get 25. Now we want to know what c is, not c squared, so we take the square root of both sides and we find out that c is 5. So we now know that that length there is 5. So now that we're finding the perimeter, we just add up all the sides. So the perimeter is one side, which we know is 7, plus the next side, which we know is 3, plus the next side, which we know is 3, and then the last side, which we know is 5. So we add up all those numbers and we get 18. Notice that I didn't include this dotted line in the middle because it's not part of the perimeter. The perimeter is only the outside of the shape. Awesome. Okay, because I was given all those measurements in centimeters, that means that my final answer needs to be in centimeters. So I say, therefore, the perimeter is 18 centimeters. Okay, let's look at the same shape, but this time let's find the area. So we can tell that the area of the shape is made up of two separate areas, the area of the triangle and the area of the square. So for the area of a triangle, we're going to need the formula base times height divided by 2 from our formula sheet. And for the second area, we know we're going to need the formula A equals length times width because that's the area of a rectangle. So for base times height divided by 2, we need base and height. So the base is 3 because, again, we established that the bottom length is 3, so this length is the same. And because that side is 3, and the entire thing is 7, that means that this other side of this right triangle must be 4. So 3 and 4 are the base and height. We plug those into the formula. We multiply them to get 12 and then divide by 2 to get 6. So that means that the area of that triangle is 6 centimeters squared. Now I'm going to look for the area of the rectangle. So length times width is 3 times 3, which is 9. So the second area is 9. Now the total area is the first area plus the second area, so that's going to be 6 plus 9, which is 15. So again, my final answer needs units, and I say therefore the total area is 15 centimeters squared. Okay, let's do one more question like this, where we look at a composite shape and find the perimeter and area. So here's a really weird looking shape. Notice that this shape is a parallelogram on the outside with a triangle that's been cut out of it and a circle that has been cut out of it. So to find the perimeter, we need to go all the way around the outside of the shape. So first of all, which is these three sides, and then this little side, this side here, and then this other little side, and then of course this circle, since that's also considered part of the outside of the shape. So when I'm looking for the perimeter, I'm going to look for clues. Here it tells me that all the way across is 20, and so is this because we have that double line saying that this entire thing is the same length as that. And here it tells me that this side is 10, and here it gives me the same number of hatches, so that means that this must also be 10. But I could also find that distance by using the Pythagorean theorem, because here is a right angle triangle, and I know that this length is 6, this one is 5 plus 3, which is 8, and I can use those two measurements to find out the third side. So, in order to find the perimeter, I need to find out what sides are missing. So here's one missing side. This one doesn't have any measurements on it. Here's another missing side. We don't know what the length of this round part is. We just know the diameter across is 5. And then, as I already pointed out, this one is an unknown. Okay. So to find that first unknown, we know we can use Pythagorean theorem, which is going to be 6 squared plus 8 squared, because 5 plus 3 is 8, and that's going to equal c squared, which is our unknown. So 6 squared plus 8 squared is c squared, which is 36 plus 64, which is 100. Now to find what c is, we take the square root of both sides. We find out that c is 10. And we should have known that already because we can see that this opposite side is 10 and it's marked as being the same length, so that must also be 10. But that's okay, we did a little bit of extra work, but that's no harm done because now we know for sure that we did that right. Okay, let's find the next missing measurement. So that's going to be for that triangle here, the white triangle that's been cut out of our bigger parallelogram. So the first thing we have to do is figure out how long is this side of the triangle. We know that the entire distance across is 20. We know this much is 2 and this much is 6. So 20 minus 6 minus 2 is 12. So that means that this length, just the blue dotted line here, must be 12. So I can use this side of 12, that side of 5 in order to find this length of c because it's the hypotenuse. So we use a squared plus b squared equals c squared because it's a right angle triangle. 12 squared plus 5 squared is equal to c squared. I'm plugging in the 12 and the 5 as the two sides. I evaluate the exponents because I'm following BEDMAS since c is almost by itself, so I'm just doing the exponents before I add. So 144 plus 25 is 169. Now I take the square root of both sides and find out that c must be 13. So I can add that into my measurements as well. We know that that distance is now 13. Okay, now the last part is to find this other unknown, which is the distance around the circle, because that's also considered part of the outside of the shape since it's like the part that's missing. So pi times diameter is the formula we're going to use here. We could use 2 pi r, but we don't have the radius. We are given the diameter. Of course, we can use the diameter to find the radius, but since we already have diameter, we might as well use the formula that includes diameter. So pi times diameter is pi times 5. Pi is about 3.14 times 5, so we get that the circumference is about 15.7. So I can plug that into my diagram there. Notice whenever I have a new piece of information, I add it into my diagram so that I can keep track of what I found. Okay, so that means that I need this distance, which is along this side. For my perimeter, I need this distance, which is along this side for the perimeter. I need this distance along that side. I need this distance along this side. I need that distance of 13 along this side. I need the 5 along here and the 6 along here. And then I also need that 15.7, which is the circle around the outside of that shape. So the perimeters, all of those sides added up, 10, 20, 10, 2, 13, 5, 6, and 15.7. So I get that it's about 81.7. Notice that I say approximately because this 15.7 is rounded, so my final answer is rounded, and I'm finished with that question. Now let's do the same shape, but we're going to find the area. So there's a few ways we could break this one up, but the easiest way is to notice that this is one big parallelogram with a circle cut out of it and a triangle cut out of it. Okay, so one big parallelogram with two little shapes that need to be cut out. That means that the total area is going to be the area of the parallelogram minus the area of the triangle and minus the area of the circle. That will leave us with just the green part. So area of a parallelogram, the formula for that is base times height. For the area of the triangle, it's base times height divided by 2. And then for the circle, it's pi r squared. So I'm going to find each of these areas individually and then plug them into my total formula. So the parallelogram is base times height. The base is 20. The height is 5 plus 3, which is 8. 20 times 8 is 160. Now I find the area of the triangle. I know that that side was 12 because the entire thing across was 20. We talked about that before. 2 plus 12 plus 6 is 20, so I know that that's that length. So base times height divided by 2 is now 12 times 5, because that's base times height divided by 2, and I get 30, because 12 times 5 is 60, divided by 2 is 30. And now I'm looking for the area of this circle, so I have pi r squared. The radius is the same thing as the diameter divided by 2, so that's 5 divided by 2, which is 2.5. Now I do my exponents before I multiply because we're following BEDMAS since the area is by itself. So 2.5 squared is 6.25 times pi is about 19.6. So I plug all of those amounts into my total formula for area, which is the area of the parallelogram minus the other two areas. So that's 160 minus 30 minus 19.6, and I get that the answer is about 110.4. So now you're going to complete question 5 on your worksheet and look at the notes in your duotang in order to review everything you need to know for tomorrow's quiz. And just keep in mind that everything we've done so far in this semester is always going to be fair game to put on a test. So you should always be reviewing. We're going to build on old material as we continue to add new material. So make sure that you're reviewing those notes in your duotang before the test. Okay, good luck working on the rest of your review. Again, just a reminder, this is what your review sheet looks like. You're now doing this last question, finding the area and the perimeter of that composite shape. You can see it's made up of a few different shapes there. Okay, thanks very much.